Hi guys, good morning. Good, I see almost all of you are there. I think there was some problem in starting the meeting. Right. Okay, so I see almost all of you are there. I think we can start. Right. Okay, let me share the screen. Okay. So people, hope you all remember what we are seeing. Okay, let me just make the page name. So this is 11th, 2006. Okay, fine. So I hope you all remember what we have been seeing. Basically, we had maybe if I just show you the previous one, I think it would be better. So 11 yesterday's class, right? Okay, so I hope you remember we started with concentration, right? I said you that the concentration nothing but it talks about the amount of solute present in the solution, right? Then we went on to see this amount again can be anything, right? This can be mass, it can be moles, it can be so many other stuff. So we went on to see first among them is percentage composition. First one was M by M, M by V, and V by V. I think we spoke about the definitions of all of them, right? And also what is this formula, right? Mass of solute divided by mass of solution into 100, right? And then we saw M by V, right? And then we went on to see V by V, right? And then we went on to see okay, this is a problem. Okay, then we went on to see this important thing, molarity is denoted with the letter capital M, right? And I have mole per liter as a thing, so we know how to define them. It is the number of moles of solute present in 1 liter of the solution, right? So I told you definition is important, and also obviously the formula is also important, right? So we went on to see if it's 0.5 m NaCl, that means 0.5 moles of NaCl present in 1 liter, and a lot of assumptions, right? If in the case of mass percentage, if they don't give you anything about the solution, we assume it to be 100, right? So in this case, if they don't give you anything about the solution, then we assume it to be 1 liter of solution. And then if we assume that 1 liter of solution, then we can easily say that the number of moles that's written here. If I assume volume solution to be 1 liter, the molarity will become the number of moles of solute. And this is the formula. Number of moles of solute divided by the volume of solution into 1000. Why we put 1000? Because we use volume of solution in ml. So we put 1000. And then we went on to see molality. Right? Molality is number of moles of solute present in 1 kg of solvent. Right? That's why I have mole per kg. So 0.6 mole, 0.6 m glucose solution means 0.6 mole of glucose present in 1 kg of solvent. Solvent here will be water. And this is the formula. Number of moles of solute divided by mass of solvent in grams. And I put 1000 because I used grams. And then we did a problem. That's it. This is what exactly we saw. Okay, right. So let us continue. Maybe we'll do one more problem just for you to refresh up all these stuff what we have seen, and then actually we can move on to the next one, mole fraction and ppm. Any questions, guys? Any questions from what we saw last class? Is there any question?
Clear, sir.
Clear. Okay, good, good, fine. Right to the question, guys. Okay. Calculate molarity, comma, mol and molality. Right, both molarity and molality of the calculate. Right, calculate molarity and molality of H2SO4 solution. I think I can't write it here. I'll go for the next page. Okay, so the question is calculate the molarity and molality of H2SO4 solution, right, which is 98% m by m, right? 98% m by m, and the density of the solution is 1.8 gram per m. Okay, so the question is calculate molarity and molality of an H2SO4 solution, which is 98% mass by mass, and the density is 1.8 gram per m. Go for it. I'll give you 5 minutes time. So see, they have just given 98%. They did not give you anything about total mass of solution. So you know what you have to assume. So if you assume what will happen, all this stuff will be there in your fingertips. Guys, don't sit idle, guys. Please calculate, do the problem. Doesn't matter if you get the answer or not. It's all about trying.
Excuse me, sir.
Yeah.
Sir, actually, Raga is not able to connect to the meet.
Oh, Raghav is not able to connect.
Yeah.
Oh, okay. Admit. Understood. Yes, now I admit it. Now he'll be able to join.
Yeah, okay, sir.
Yeah, I don't know why they change the settings like this. Generally, they just click the link, they'll be able to join. But I think the settings changed. Okay, cool. Okay. Any answers, guys? Or at least you found out the concepts, how to do it. Right. First things first. Now, when I say 98% H2SO4, what do you mean by this? Tell me first.
Sir, the molar mass of that will be 98 grams.
Molar mass? Molar mass of H2SO4 is 98. But does it come from this one, molar mass?
Sir,
Yes.
sir, in the solution, 98% of there is 98% of H2SO4 is present in the total solution.
Okay. Total solution. So that means how do I? So there is nothing given about the total mass of solution, right? So if nothing is
So
given
we
about total
assume
mass
that
of solution, we
total
assume
mass is
that
100 grams.
absolutely correct. So what? So then, okay, all the what you're telling is correct. So what exactly I should do now? So this means what? 98% H2SO4 means what then?
Which means mass, the percentage will be mass of the solute.
Correct. So I would say that 98 grams of H2SO4 is present in 100 grams of the solution. This is what it means, right? Again, solution will contain two stuff. First is H2SO4 and water, obviously, right? Solute plus solvent, correct? So, and I know that the H2SO4 now is 98 grams. So obviously this should be 2 grams. Correct. So I found the mass of H2SO4 and I found the mass of H2O. That's why I told you the definitions are very, 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 very important. Right. So 98% means 98 grams of H2SO4 is present in 100 grams of total solution. Okay. Now this point is clear for us. Correct. Now I can easily calculate the molality now. Small m. What is the formula? Number of moles of, okay, in this case, solute, we write it as, right, number of moles of H2SO4 divided by mass of, mass of
Solvent.
Solvent here is H2O into 1000, right? Okay, so now number of moles I have to calculate. I know the mass of H2SO4. So number of moles of H2SO4 would be given mass is basically 98, and molecular mass of H2SO4, if you calculate, again, it will be 98.
98, yes, sir.
Right? So it will be 1 mole. Done? Right? So if I calculate molality small m, that would be number of moles of H2SO4, that is 1, divided by mass of H2O, and I count out mass of H2O to be what? 2 grams into 1000. So this would be 0.5 into 1000. Correct. So 0.5, really, this much a big value is coming. Okay, no issues, right? So 0.5 into 1000 will become 500. 500 m is what is the answer for molality. Very easy, right? So I just converted mass percentage into mass itself by assuming that the total mass of the solution is 100 grams. As simple as that. Okay, fine. Now, for molality, sorry, capital M, I require number of moles of H2SO4 divided by volume of the solution in ml into 1000. This is what we need. I already have number of moles of H2SO4, that is 1. All I need to find is the volume of the solution, right? So for that, only density is given to you. Correct? Right. So now, density is equal, density of solution is equal to mass of solution divided by volume of solution. What is mass of the solution?
100 grams.
100 grams. That's what we assume, right? So mass of solution is basically 100 grams divided by the volume, and this value is how much? 1.8 grams. 1.8 gram per ml. So this value is 1.8 gram per ml. So volume would be 100 divided by 1.8 ml. That's the volume, right? So we'll substitute the volume. You found out whatever the volume of solution you found out. Here, you already know the number of moles. So this should be 1 divided by 100 divided by 1.18, it's 1.8. Right? Okay, so 1.8 in the numerator, I put 1000. So this will eventually become, I know whenever it's like this, I write it as 1 divided by 100 into 1.8 into 1000 mole per liter. That would be the answer. Okay. Is there anybody confusion? How do I convert this into this? Anybody has questions? How this 1.8 came here? This is like 1.8 divided by 1. So I take it, numerator will become denominator, denominator will become numerator. That's how it came like this. Okay. Guys, everybody understood how we did the problem? Very, very simple. Like the only thing you have to assume is this: 98 grams of H2SO4 present in 100 grams of the solution. Then you can see the assumption how well it's working. For finding the density, we use the mass of solution. For finding the mass of solvent, that is 2 grams, again we use the assumption only. Okay, right? Is there any question, any doubts from how we solve the problem? Okay, I hope it's very clear. Right, fine. Next thing, guys, I want to tell you one thing. Right now, if I mix, okay, if I mix two solutions, say I have H2SO4 solution, another H2SO4 solution I have. Both are H2SO4 only, but only the concentration is different. Say, for example, molarity is different. Okay, say if I do the question, I think you'll understand. Take down the question, guys. Take down the question, and I will solve the question. You are not going to solve. I am going to solve. Okay, take down the question. Maybe first you can take this down, whatever I have written, right? And then you can take the question. Okay, fine. The question is, find the molarity of a solution. Find the molarity of a solution obtained. Find the molarity of a solution obtained by mixing 750 ml of 0.5 m HCl and 250 ml of 2m HCl. Okay, the question is, find the molarity of the solution obtained by mixing this two, that is 750 ml of 0.5 m HCl and 250 ml of 2m HCl solution. Okay, so two solutions, both HCl solutions, different molarity, different volume. I am mixing. I'm asking you what is the new molarity formed. Okay, the question is very simple. Right, fine. Now, what we have to do about this? Okay, now remember, people, answer this question, or please understand, try to understand. Now, I will have, say, some X moles of HCl, right? Say here I have X moles of, assume that I have some X moles of HCl, and here I have some Y moles of HCl. Okay, right. Now, when I mix these two solutions, right, obviously the number of moles in the first solution and the number of moles in the second solution will get added up. Total HCl will be X plus Y. Correct? Okay. And again, total volume will again get added up, because obviously I add 750 ml, 250 ml. Now the total volume will become 1000 ml. No issues, right? So now, if I can calculate what is the number of moles of HCl in the first solution and number of moles of HCl in the second solution, and I add up, and then I also add up the volumes, right? So basically what you understand is molarity is number of moles of solute divided by volume of solution in ml into 1000. Very simple. Right now, since I'm mixing two solutions, right? I have I have one solution, second solution. So I have to add. So if at all I have molarity of mixing will be what? Number of moles in the first solution of solute and number of moles of solute in the second solution divided by volume of the first solution plus volume of the second solution. This whole thing would be in ml, and I have to put 1000. Correct? Right? So I have to add the number of moles and I have to add the volumes and divide them. That's it. That's how I'm going to get the molarity. Sorry, overall molarity. Okay. Now the next question comes to our mind. This can be very easily calculated. V1, V2, we know 750 ml, 250 ml. We can easily calculate 1000 ml. Done. But how will you calculate number of moles from first solution and number of moles from second solution? Tell me, any idea?
Sir, it is already given that 0.5 m of HCl. So 0.5 m means 0.5 moles in 1 liter of a whole
Okay,
solution.
okay. Correct. 0.5 moles of HCl is present in 1 liter of solution. But how much volume I have here? 750 only. So you cannot take the number of moles as 0.5 here. I told you, you can assume the volume to be 1000 ml or 1 liter if volume is not given to you. Correct, right? So now here the volume is given to you. If the volume is not given, then yes, you can directly take 0.5 m as 0.5 moles. Again, 2 m as 2 m moles, 2 moles. But here both volumes are given. Okay.
Sir,
Now
0.5 into 750 ml, sir.
yes,
sir.
correct. That's what we do. Right. So now you can use the same formula again. Say now I have molarity 1 is equal to number of moles of HCl in 1 divided by volume of the first solution into 1000 if it's in ml. Correct. Same way, I can write molarity of the second solution, which is given to us, is number of moles of HCl in the second solution divided by the volume of the second solution into ml into 1000. Okay, so now I know molarity. Now look at the question. They have given the volume for the first solution and they have given the molarity. Same way, volume of second solution and the molarity of second solution is given to us. Correct. So now this value can be calculated. Number of moles of HCl in 1, number of moles of HCl in 2 can be calculated very easily. How do I calculate that? That would be equal to number of moles of HCl in 1, right? Number of moles of HCl in 1 would be molarity of 1 into the volume of the first solution divided by 1000. Same way, number of moles of HCl in second solution would be molarity of the second solution, volume of the second solution divided by 1000. Done. Now you can easily calculate the number of moles of HCl in 1 and number of moles of HCl in 2, and you take down these two values and you put it here in this case, right? And then you calculate the molarity. Okay, right? Can you do the problem now? And tell me the answer
sir.
quickly. Yeah, go for it. Go for it. I hope everybody understood what we are trying to do here. Nothing. We are just using the formula 2 times. That's it. So basically number of moles of HCl from 1 would be 750 into 0.2 divided by 1000. And here it would be how much? 250 into 2 divided by 1000. I think I calculate easily. So this will be 1 time, 4 time. So this would be 0.5. 2 by 4 is 0.5. And here it will be 3 times, 4 times. So 3 by 4 is 0.75. 0.75 into 2 will become 1.5. So here it is 1.5 moles. Here it is 0.5 moles.
Sir,
So
molarity is 0.885.
Okay, fine. We'll calculate. We'll check. Okay. So now we calculated the number of moles of HCl in 1, number of moles of HCl in 2 as 1.5 and 0.5. So if I calculate the molarity of mixing, that would be 1.5 plus 0.5 divided by 1000 into 1000. As simple as that, right? So 1000 gets cancelled. So 1.5 plus 0.5 will become 2m. That's the answer. I don't know how you got something 8 you said. I don't know how you got that. This is very simple. I just substitute whatever I got here in this equation. Molarity of mixing N1 plus N2 divided by V1 plus V2 into 1000. N1 and N2 I calculated from the molarity equation itself, right? And then I just substituted. That's it. The answer is 2m. Anybody got this answer? Okay. At least everybody understood. Can I get a yes?
Yes, sir.
Sir, now,
Understood.
Yes.
sir, what is this
Yeah.
answer, sir? It is
Sir.
for molarity or molarity? I got 0.875.
Sir, how is it 1.5 moles in first, sir?
Sir, you
Okay.
multiplied with
Yes, sir.
0.2, sir. 0.5.
I'm sorry.
Yes, sir.
I'm sorry. My bad. Yes, that's a small mistake. It should be 0.5, correct. So if it is 0.5, so basically 0.75 into 0.5, right? So 0.75 or, okay, 0.75 into 0.75 into 5 is how much?
375.
375, so
385,
it
sir.
should be 385.
385. Yes, sir.
Okay, fine. So it should be 0.385 moles then.
Oh no, sorry, sir. It's 375. My bad.
77.
Sorry, sir.
Okay, fine. Whatever it is. Calculation you can do. So it's basically going to be 0.375. So the overall number, now this is 0.5, this is 0.375. So this is not 1.5 then. I'm sorry. This
It will be
B.
0.875.
Correct, right? So you will get, this is 0.375 plus 0.5 will become 9,000 gets cancelled. That is okay. So it will be 0.875 m. Yes, absolutely. What you got is correct. Okay, it's my bad. I just small mistake, right? I hope everybody understood here. Okay, what we did,
Yes, sir.
right? Okay, cool. Now, instead of doing so much, right, I'm going to give you a simple equation. Okay, now the simple equation, whenever these kind of questions comes, right, whenever they ask you molarity of mixing, whenever these kind of question comes, you directly use this equation, m1 v1 plus m2 into v2 divided by v1 plus v2. If it is an ml, you put 1,000 in the numerator. Very simple. Now again, what is m1 v1? M1 v1 is basically going to be the n1, right? You see here, right? If I multiply molarity into volume, I'm going to get number of moles. Again, molarity into volume, I'm going to get number of moles. Okay, so molarity m1 v1 will basically be n1, m1 v2 will be n2 divided by v1 plus v2. This equation you can directly use whenever these kind of question comes to you. Okay, whenever these kind of questions come to you, you can remember this formula, or you can go by the logic. Logic is basically number of moles will get added up, volume will get added up. So you calculate number of moles using the molarity equation, again number of moles from the second equation, and then you substitute it. Either way, you're going to get the same answer. Right? Cool. Now, I think now we'll concentrate on the other concentration terms. Right? Now, the fourth, now we saw percentage composition, molarity. The fourth one we are going to see is this mole fraction. Right? And is denoted by the letter X. Okay. Now we'll take to the definition first, and then we'll see what is it. Okay, just give me a moment. Just a moment. Something in the chat. 1.5, I don't know for what, maybe for the previous question. I'm not sure. Anyways, right? Okay, so mole fraction definition we'll take now. Right. It is the number of moles of a particular component. It is the number of moles of a particular component in a mixture. Right? It is the number of moles of a particular component in a mixture when the total number of moles of all the components present in the mixture, then the total number of moles of all the components present in the mixture is 1. Okay, I'll repeat the statement, guys. It is the number of moles of a particular component in a mixture when the total moles of all the components present in the mixture is 1. Okay, that is the statement. Okay, now it's very simple, right? Now I say I mix two, like you know what is a mixture, correct? A mixture is something I mix two or three. Okay, I think hope you remember we spoke about pure substances, mixtures in your 9th class. I don't know whether you remember. This is matter around this pure from the chapter name. I think you should be remember there's something called as pure substances and there's something called as mixtures, right? So how do you form a mixture? By mixing 2 or more pure substances, correct? So now again, that's what we do in a solution also. One solute, pure substance, solvent, pure substance, I mix them, correct? So what the statement tells you is, if the total, say I have some n, say I have 2 components, okay, in a mixture, right? I have 2 components in the mixture, right? So what it tells you is that when I add the number of moles of the first component and I add with the number of moles of the second component, and if I find that the total number of moles is 1, right? So in that 1 mole total mixture, how much moles is N1 and how much moles is N2 is what is a mole fraction. In total 1 mole, how much is the number of moles of one of the component? Very simple, right? Now, actually, you will be able to correlate this with mass percentage. Is it not? What mass percentage is? If I have total 100 grams of the solution, in that, how much is the mass of the solute? As simple as that, right? Same way here, now the difference between those two is in mass percentage, the scale is between 0 to 100. Correct, because we are like when the total mass is 100, then what is the solute mass, right? But here in mole fraction, the scale will be from 0 to 1. That's the only difference. Second, okay, I will say 2 differences. First difference is the scale, that is 0 to 100 in mass percentage, and here it is going to be 0 to 1. And second thing is here I use mass or volume, here I use number of moles. That is the only difference. Okay, now once you understood this, the finding out what is the fraction, what is the formula is going to be very, very easy. Okay, now like maybe I'll give you an example before we go to the formula, right? Now, for example, if I tell you that X, assume that I have something like, say a mixture of, I have H2 gas plus N2 gas in a vessel. Okay, right. Now, if I tell you that X of H2 is some 0.3, that means what? If number of moles of H2 plus number of moles of N2 is 1, in that the number of moles of H2 is 0.3. That's what it means. And obviously, you know what will be the number of moles of the other one. Number of moles of the other one will be how much? Number of moles of N2 would be
0.7.
0.7. Very simple, very simple. Right? Okay, that is exactly what it means. Now, you can easily get the formula, right? Say, assume that I have 2 components A and B in a mixture. Okay, I have 2 components A and B in a mixture. Say now, XA, basically that is what is the mole fraction of A, right? Mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. As simple as that. Same way, I can write XB as number of moles of B divided by number of moles of B plus number of moles of B. That's what is XA and XB. Very simple, right? Don't you see it is very, very similar to the mass percentage? It is like the mass of the solute divided by mass of the solution, that is solute plus solvent. And I only thing I put is 100 here because I want in terms of percentage. Here it is going to be in terms of fraction. Fraction will always be lesser than, mole fraction always lesser than 1 because the scale is between 0 to 1. Okay, I hope you understand the correlation between mass percentage and your mole fraction. The same thing, number of moles of, mass of the solute divided by mass of the solution, that is solute plus solvent into 100 we put. Here we take mass of the solute, number of moles of solute divided by number of moles of total solution, in the sense that number of moles of solute plus number of moles of solvent. And I didn't put 1,000 here. Sorry, I didn't put 100 here. That is the only difference. Okay, and one more thing what you understand from the previous example, this example is If I have only two components, right? If I have only two components, right? Before we see this, like remember, how many other components I have? Okay, how many other components I have? Say I have x1 plus x2 plus x3 plus x4, so on so forth up to x, and say I have n components, right? So if you sum up all, this is plus, guys. Okay, so if you sum up all the mole fraction, you should be getting the value of 1, because that is what the definition says. Total 1 mole, in that how much? Obviously, if I calculate the total mole fraction, should be equal to 1. Or it's like percentage. If I calculate everything in terms of percentage, it should be 100%. Just like that, total should be 1. Okay, so if I have only two components, it's very simple to write, isn't it? X1 plus x2 will be equal to 1. So if you know one of them, say if I know x1, I can easily calculate x2. That's what we did here. If I know the mole fraction of H2 is 0.3 and I know the total will be 1, obviously the mole fraction of N2 will be equal to, N2 will be equal to 0.7. Right. Now you can assume the mole fraction to be equal to, again that I'll tell. You can okay, we can assume if, okay, something we'll write like this. If total moles not given, right? If total number of moles is not given to you, then you can assume the mole fraction as the number of moles itself. Please remember this. Again, coming from the definition. Okay, if total number of moles is not given to you, right, but only mole fraction is given, you can assume the mole fraction to be equal to number of moles, obviously assuming that the total moles is 1, obviously, right? So you can assume the total mole will be 1, and obviously that will eventually find out, you'll eventually get that the mole fraction can be equated to the moles, number of moles directly. Okay, but this has to be done only if total mole is not given. If total number of moles is given, then you have to use the formula. This is the formula. Okay, right? So that is what is about mole fraction. Very simple. Very 90% of times you will not be using this, whatever I told you here. Like total moles is not given, you will assume it to be, but sometimes you will use it, but 99% of times you will directly use the formula. Na divided by Na plus Nb, same way Nb divided by Nb plus Na for mole fraction. Okay, right? Fine. So that is about mole fraction, and the last concentration term we have is ppm. ppm full form is parts per million. Okay, now this is not that important to us, okay, because problems also will not come that much. Now here it's exactly similar to mass percentage. Okay, it is exactly similar to mass percentage, except that the scale there was 0 to 100 in case of mass percentage, right? Now in case of ppm, the scale will be from 0 to 1 million. 1 million is 10 to the power 6. That is the only difference. Okay, now the ppm formula will also be very similar. It's equal to mass of the solute divided by mass of the solution. Now, if it is mass percentage, you put 100. Now, if it is ppm, you put 10 to the power 6 in the numerator. That's it. This is the formula for ppm. Right? So the only difference is for 100 grams, we say how much is the solute. If I have 1 million grams, what is the mass of solute? Is basically what is ppm. Okay, right? So like this is again not that important. ppm is not that important, but definitely this mole fraction, other stuff what we saw are very, very important. Okay, maybe if I do some problem, you will be able to understand better. I will look for a problem for you. Okay. Right, maybe we'll start with some simple question. Okay, fine. Maybe I'll not give the question which is there in the book. I'll give you like this. Okay, tell me a question. Three moles of H2 3 moles of H2 is mixed with 3 moles of H2 gas. Okay, 3 moles of H2 gas is mixed with 5 moles of N2 gas. Okay, 3 moles of H2 gas is mixed with 5 moles of N2 gas. Right? So you have to find mole fraction of H2 and mole fraction of N2. Both of them you find. Okay, the question was 3 moles of H2 is mixed with 5 moles of N2, right? Find the mole fraction of H2 and X2. I mean H2 and N2. It's a direct formula substitution. I don't think you should be requiring so much time.
Three by 8 and 5 by 8.
3 by 8 and 5 by 8.
Yeah, very simple, right? So I write X of H2 will be number of moles of H2 divided by number of moles of H2 plus number of moles of N2, right? So I told you number of moles of H2 as 3, number of moles of H2 as 3, and number of moles of N2 as 5. So it will be basically 3 by 8, right? 3 by 8. Now, you again don't have to calculate for N2 because I know X of H2 plus X of N2 will be equal to 1 that I mentioned, right? Total mole fraction of all the components, if you sum it up, will be equal to 1, right? So now I know this is 3 by 8. So now you can calculate this one. So I think it will be, again easy to calculate. So it will be 5 by 8, right? N2 would be 5 divided by 8. You can easily calculate. Or you can again use the formula, a number of moles of N2 divided by number of moles of H2 plus number of moles of N2. Again, same thing you will get. Very simple question. Okay, it's a direct formula solution. Okay, now we'll do little more tougher problem. Okay, take on question. An aqueous solution of ethanol is 46% by mass or weight, however you want to call it. Okay, an aqueous solution of ethanol is 46% by mass. Okay, so you have to calculate mole fraction of ethanol, that is C2H5OH, and also calculate the mole fraction of water. Obviously, if it's an aqueous solution, we know the solvent is water. Or even if it don't tell you anything about the solvent, by default it is water. Okay, so they have given that the solution is 46% by mass, and I want you to calculate what will be the mole fraction of ethanol and mole fraction of water.
Sir,
Yeah.
sir, it's already given, sir. 46% means 46 by 100. So 100 is
by 100.
100 is
What
the
do you mean?
solution. 100 is the solution.
Okay.
46 is the mass, and then the water will be
mass
100
of
by
water.
mass of the ethanol. Mass of ethanol.
46 by 100 will be the mass of ethanol, or 46 will be the
46
mass of
grams will be the ethanol. Sir.
Correct.
100 will be the grams of the total solution, and
correct. Mass of H2 will be the remaining 54 grams. Yes, correct. But you have to calculate the number of moles. For calculating mole fraction, we don't need mass. What do we need?
Sir,
we need
1
number
by
of moles.
1 by 4.
we have to
1 by
simplify
4
46 by 100, sir.
Okay. Why are you putting 100? I don't understand. Why are you putting 46 by 100?
That's 100 is the solution, mass of solution.
Okay, 100 is the solution. I understand. See, look at this. When I say 46% by mass ethanol, what do you mean by this? 46. Okay, sorry, 46. Right. I have 46 grams of C2H5OH in 100 grams of the solution. Done. Again, this solution will contain C2H5OH as well as water. And I know this is 46 grams, total is 100. So I know the mass of H2O will be 54 grams. Done. Now, for calculating X of C2H5OH, it would be number of moles of C2H5OH divided by number of moles of C2H5OH plus number of moles of H2O. So now I know the mass. I know 46 grams is the mass of C2H5OH and 54 grams is the mass of H2O. But I have to calculate the number of moles. And I know number of moles is this. Number of moles of C2H5OH would be given mass by molecular mass. Given mass is 46. Just now we calculated. Divided by molecular mass of C2H5OH.
46.
46 only.
Yes, sir.
Yes, sir.
Okay, fine. 46. That would be 1 mole. Right? Same way, number of moles of H2O would be how much? 54.
54 by
divided
18.
Which would
So
be
that's
3
3.
moles.
Yes, sir.
Done. Right? So now I can easily calculate what is mole fraction of C2H5OH. That would be number of moles of this 1 divided by 3 plus 1, which is 1 by 4, which is 0.25. 1 by 4 will be 0.25. And I have to calculate mole fraction of H2. Again, you don't have to calculate like this. You can write 1 minus mole fraction of C2H5OH. Right? 1 minus mole fraction of C2H5OH. So that will be 1 minus 0.25, which will be 0.75. That's it. Very simple. Okay.
Got it, sir.
Right? Very good.
I got
There is no
confused
need to
with
put
number of moles and gram.
Understood. No issues. Right. All you have to use is number of moles here for mole fraction. Okay, maybe one more question like this. Maybe you will get accustomed. See?
Yes, sir.
Yeah. Going okay. Okay, maybe I'll do one more easy question and then we'll go for one tough question. Right. Take on the question. A mixture contains 9.2 grams of ethanol. A mixture contains 9.2 grams of ethanol and 18 grams of water. Okay, a mixture contains 9.2 grams of ethanol and 18 grams of water. Find the mole fraction of ethanol. Again, it's direct formula substitution, right? Find the mole fraction of ethanol.
9.2 by 27.2.
The same mistake you're doing. What mistake you're doing?
Calculating
mass.
mass instead of moles.
Correct. This is mass given to you. You have to calculate number of moles.
Okay.
Right? Yeah, go for it. Okay, so it is basically 9.2 grams of C2H5OH and 18 grams of H2O. Right? So they're asking you what is mole fraction of C2H5OH, and I know the formula. It will be number of moles of C2H5OH divided by number of moles of C2H5OH plus number of moles of water. Now this.
So 1 by 6, sir. Answer.
Okay, fine, cool. I think it should be correct. So fine. So now first I can calculate number of moles of C2H5OH, which would be given mass by molecular mass. Given mass is 9.2, molecular mass is 46. So this I can write it as 2 times, right? So this is 0.2, right? So this is 0.2 moles, right? Okay, same way, number of moles of water is given mass by molecular mass. They are given 18 grams of water. So 18 divided by 18, which is 1 mole. Okay, right. Now I can easily substitute it here. It is 0.2 divided by 0.2 plus 1, which will be 0.2 divided by 1.2. You have to calculate this, whatever the value is. Okay, so 0.2 by 1.2 would be the answer. Very, very simple. They have given you the mass, convert into moles, and calculate the mole fraction. As simple as that. Okay, I hope everybody is picking up. No, there are no doubts. If there's any doubt, please don't hesitate. Please ask me. Okay, we'll go to the next question now.
Sir, this doesn't
Yeah.
have any unit, no, sir.
Yes, correct. Mole fraction has no unit because numerator is moles, denominator is also moles, so mole will get cancelled. No unit. Mole fraction has no unit. Okay, good. Fine. The question says like this. Mole fraction of glucose in its aqueous solution. Mole fraction of glucose in its aqueous solution is 0.1. Okay, the mole fraction of glucose in its aqueous solution is 0.1. Okay, the question is find the molality, small m, right? Find the molality of the glucose solution. Find the molality of the glucose solution. Okay, now see, they have just given the mole fraction and there is nothing about total number of moles. So you know what you have to do. Okay, if total number of moles is not given, what will you assume, guys?
1.
We'll assume the total number of moles to be 1. Okay, if I assume total number of moles to be 1, then what will happen?
Mole fraction of
If I-
water will be 0.9. I mean,
Mole fraction of water would be?
0.9.
Okay, that is fine. Mole fraction of water would be 0.9. Mole fraction of glucose is 0.1. So if I assume that the total number of moles of the solution is 1, what will come out to be?
The mole fraction is equal to number of moles.
Correct. Right, I mentioned this here. Where is it?
Sir, is it 0.56?
I'm not sure. Let me check. Let me check. Okay. So that's what is given. So if total number of moles is not given to you, you can assume that the mole fraction is equal to the number of moles directly. Whatever. So now in this case, you can take the number of moles of glucose as 0.1. Even though it's only mole fraction, you can assume the number of moles of glucose to be 0.1 and number of moles of water to be 0.9, assuming the fact that total number of moles is 1. It's not assuming, it's coming from the definition. Okay, right? Fine. I think maybe I'll give you 1 more minute for everybody to calculate this. Now that you know this is how we have to do it. Okay, fine. So they have given that the mole fraction of C6H12O6 is 0.1, right? And they have not given anything about the total number of moles. So what we are going to do, we are going to take the mole fraction as the mole itself. That is, number of moles of C6H12O6 is 0.1. We take it like this. And obviously, same way, if I know that more, if I sum up the mole fraction of glucose and the mole fraction of water, I should be getting 1. Correct? I'll write number of moles of glucose plus, not number of moles of glucose, mole fraction of glucose plus mole fraction of water is 1. So obviously, I can now write mole fraction of water is 0.9. And since again, I'm assuming I can write number of moles of H2O is 0.9. Okay, I think this is the first step. This you will do, right? And then calculating molality is very easy, right? Molality, what is the formula? Molality small m is number of moles of C6H12O6 divided by mass of solvent. Mass of the solvent here is water in grams, and I put 1,000. Right now, number of moles of glucose I already have, that is 0.1. Right, but I have to calculate what is the mass of H2O. All I have is only the number of moles of H2O. Right, so now if I do that, right, so I know number of moles of H2O would be given mass of H2O divided by molecular mass of H2O. I know it is going to be given mass of H2O divided by 18 grams. 18 is the molecular mass of H2O. Number of moles of H2O I know is 0.9. So basically the mass of H2O, okay, this is molecular mass, guys. Okay, so the given mass of H2O would be 0.9 into 18. Okay, so now if I substitute all this in this equation, I know the number of moles of glucose is 0.1, number of moles, mass of H2O we just calculated, which is 0.9 into 18 into 1,000. This would have been the answer for your question. Okay, anybody got this? Not the final answer, but this one you got, anybody? What was the problem? The problem was finding out the mass of H2O. Was that the problem?
No, sir, it was a simple one.
Okay, fine. I hope everybody understood how we did this problem. All we did is, since total number of moles was not given, I assumed the mole fraction to be the number of moles itself, right? And then it is just formula substitution. Like I have number of, like molality, will be number of moles of this divided by mass of water into 1,000. Number of moles of this we already have in the solution, in the question itself, indirectly as 0.1. Right, now I have to calculate what is the mass of water. Right, for that I need to use the number of moles formula. Given mass by molecular mass, number of moles I know, molecular mass I know. Now you will be able to calculate what is the given mass, and that would be 0.9 into 18. And that's what I substituted here, 80,000. That's it. Okay, I hope everybody is catching up. Guys, I wanted to be very frank. Is there anyone who is finding, oh, there are so many chats which I'm not seeing. Okay, and I think we're all telling the answers to these questions. Okay, fine. So guys, I wanted to be frank with me. Is there anybody who finds it difficult, whatever the problems we are doing, sir? Like I'm not telling, but I actually find it difficult. Is there anybody like that? You can be frank, guys. We are all, this is all your friends and I am your teacher. Okay, there is nothing to feel shy. There is nothing to feel inferior here. All I want to know, all I want to get is some confidence that you are understanding. Is there anyone who does not understand whatever I'm saying, or I'm going so fast? Is there any problem like that?
Sir,
Yeah.
sir, I can't understand. I not understand. Like I don't get the mole fraction definition, sir.
Okay, mole fraction definition. Okay, now very simple, right? Mole fraction, assume that I have a mixture. Okay, I have so many gases, or say solute and solvent are mixed. Okay, now if I mix them, there'll be some number of moles of solute, there'll be some number of moles of solvent. Okay, now what we do is, if I have the total number of moles, that is number of moles of solute plus number of moles of solvent, to be equal to 1. Okay, total number of moles, if it's 1, then what is the number of moles of solute is what is the mole fraction. Okay, just like we speak in terms of percentage, right? In total 100, how much is the solute in mass percentage? In this case, I'm talking in terms of number of moles, and I'm reducing the scale from 0 to 1. If I have total 1 mole, in that how much is the solute is what is my mole fraction.
Okay, sir, got it.
Okay, guys, is there anybody else? Is there anybody else who didn't understand the problem or anything? Sir, you're going so fast. I'm not able to understand. Maybe you should do still more steps you have to do in the problem. Any kind of suggestions are always welcome. Is there anything like that, guys?
Sir, can we solve more problems, sir?
Definitely we'll solve. That is all it's all about. This problem, so the entire chapter is going to be full of problems only. And even in your exams, you are not going to get any, define this, define that, maybe 1 or 2 questions. But 90% of questions coming from this chapter will only be problems. We will do more problems. Don't worry.
Okay, sir.
Right.
Okay.
Any other concerns, guys? Any other concern? I know only like some of you keeps on frequently speaking, and I know who and all speaks and who and all doesn't speak, right? So I like, for the persons who are speaking, I understand whether they understood or not. But for people who are keeping quiet, for whatever be the reason, that would be difficult for me to understand whether what you are going through. Okay, if at all you find any problem, if you don't know, if at all you don't want to tell it now, you can always personally WhatsApp me, sir, this problem I have, sir, like, can you please do like this, I will feel better. Anything is welcome, guys. Anything is welcome. If you don't want to tell in the class, you can tell me personally. I am not going to judge you, right? You came here for your betterment, and that is my responsibility, correct? For your betterment is my responsibility. And if you are not able to tell me what exactly your problem is, how will I make you better? Right? If it's a normal class, like say I see you, I understand. Okay, looking at the face, I understand. Okay, this guy didn't understand. This girl didn't understand. But in these online sessions, it's very, 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 very important for you to be communicating with me. Right? This communication gap will be a very, very big problem in this kind of online classes. Right? Any issues, anything, say even you ask me to repeat 1 more time, 2 more times, 3 more times, I will be glad that at least you're asking. Right? But if you're gonna keep your mouth shut, like say saying yes when I ask you to say yes and you say just yes, even though you didn't understand, the losing part is going to be yours. Okay, because I try my level best, to make sure that everybody understands. It's not like for only good students I teach. Good students, anyways, whether I teach or I don't teach, they will eventually do it. Right? But for the average kids and the people who are finding it little difficult, you know which question you are in, and there is nothing to feel wrong. Okay, maybe you are like someone is good at studies, they will not be good at something else. Maybe you will be good at something else but not good at studies, right? There is nothing wrong, no judgments passed, no criticism, nothing. Okay, so please feel very, very free to say whatever it is for that matter. Okay, right.
Sir, I have a
We'll
doubt.
continue. Yes, Kana, tell me.
The molality will differ for both the solvents in the solution.
Can you please ask the question again?
Sir, for example, now in this question, we have to find the molarity of glucose, or we have to find the molarity of water.
Okay. That's the question, right? So the thing is, generally, when whatever it is, molarity or molality, we calculate only for solute. I know. I hope you understand how to know which is solute, which is solvent. Is there a problem in that?
No, sir.
Which is a solute? Okay. So generally we take only the solute. Like we calculate the molarity of only the solute. But if at all they want you to find it, say for example, in this case, they didn't mention anything. I just asked you to find the molality and you calculated the molality for glucose. Correct. But this is by default. But if they want you to find the molality of water, that is the solvent, they will give it to you in the question. Okay. Unless and until they mention anything like that, you calculate only for the solute. Right. And the only difference would be instead of putting number of moles of C6H12O6 here, you'll be putting the number of moles of water here. That's the only difference.
Yes,
Okay.
okay.
But 99% of times, I would even say 100% that they will not ask you anything like that. When I say, now, whatever be the concentration term, we calculate only for the solute, not for the solvent. Okay. Right. Any other question?
Could you please repeat the definition of the ppm?
ppm, I didn't give you any definition, Kanna. Like, okay, if you can tell you the definition, please take the definition for ppm. It is the mass of solute. It is the mass of the solute present in 10⁶ grams of the solution. It is the mass of the solute present in 10⁶ grams of the solution. Very similar to mass percentage. Instead of 100, I put 10⁶. Nothing else. Okay. Right. Anything else, guys? Anything else you want to know? Anything else you want to ask me? Anything else? Okay, fine. I suppose we are clear. I have made my point very clear.
Sir?
That, yeah, please.
Sir, what if there are two solutions, sir?
In the sense?
Sir, like suppose aqueous solution of glucose is mixed in aqueous solution of ethanol.
Okay.
And they are asking to find the molality.
No. That cannot be asked. Right. I can say if I have one aqueous solution of glucose, one concentration, I have another aqueous solution of glucose, some other concentration that I mix. Yes, they might ask you the question. Right. But if I mix two different solutions itself, basically that will make sure that I'm going to have a chemical reaction happening. That will be the next part. Right. If I mix, say, just like this, say, if I have to give you an example, sorry, I'll give you an example like this. Say, I tell that say 50 ml of 0.5 m HCl solution is mixed with 100 ml of 0.5 m NaOH solution. They will give like this, right? And they'll ask you, obviously, I know HCl plus NaOH will form NaCl plus water. I know this equation, correct? Now, you know this information, you know this information. They will ask you to find what is the number of moles of HCl. That can be asked, right? So, but you like mixing this and this, calculating the molarity of the solution? No, it doesn't exist, because when I mix these two, they're going to react and they're going to form a new compound. I can find the molarity of the new compound. Yes, absolutely, that we can find. But like these two different solutions mixing and just calculating the molarity will not work.
Yes, sir.
Okay.
Got it, sir.
Right. Okay. Any other question? Okay, fine. Cool. We'll continue with the problems. Okay. Okay. Fine, take this down. Water is evaporated. Water is evaporated from 135 ml of water is evaporated from 135 ml of 0.188 m. Write it. 0.188 m K2SO4 solution. Right, water is evaporated from 135 ml of 0.188 m K2SO4 solution until the volume becomes 105 ml. Until the volume becomes 105 ml. Right, now the question is, find the molarity of the new solution after evaporating. Molarity, I would say molarity after evaporation.
So what was the volume?
Initial volume was 135 ml. That gets converted to 105 ml. Okay, I'll repeat the question, guys. Water is evaporated from 135 ml of 0.188 m K2SO4 solution until the volume becomes 105 ml. Right? I want to know after the evaporation, what is the molarity? I know before evaporation it is 0.188. Right? After the evaporation, what will be the molarity? That's the question. Okay, guys, now answer this question. Like, say, I obviously understand that the water, like, say, water is evaporating. I understand. Now the question is, will the number of moles of K2SO4, again, look at this very carefully. Number of moles of K2SO4, will it change before and after evaporation?
It won't change.
It won't change. That is the clue here. Okay, fine, go for it. So if you can find the number of moles of K2SO4 before evaporation, that will be the number of moles even after the evaporation. Only the volume will change. I think I almost gave you the answer how to do it.
0.188 m is the number of moles, or
No, that is the molarity. How will you, if you know the volume, initial volume is 135 ml, you know the molarity, can you calculate number of moles?
yes, sir, if you multiplied it.
Correct.
Sir, molarity will be 0.24 moles per.
0.24. Okay, fine. We'll check it. Yeah, it should increase, correct? See, the concentration has to increase, right? Because I'm decreasing the amount of solvent. Correct. So obviously it should be greater than 0.188 for sure. Because I'm decreasing the amount of water. The solution is becoming more and more concentrated. Right? So the concentration has to increase. By that logic, yes, your answer technically should be correct. We'll see how it comes out to be. Okay, fine. So now guys, let me help you out. Okay, so let me calculate first the number of moles of K2SO4. Okay, now for that I know the molarity big M. Okay, we'll fine. Molarity big M will be number of moles of K2SO4 divided by volume of the solution in ml into 100. Sorry, into 1000. Right now, molarity we know what is the initial molarity. 0.188 is equal to number of moles of K2SO4. I don't know. Divided by volume of solution. Initial volume is 135 ml into 1000. Right? Okay, so now I can easily calculate the number of moles of K2SO4 as 0.188 into 135 divided by 1000. Now you can do the calculations later. Okay, so that is the number of moles of K2SO4. And please understand, we are not doing anything with K2SO4. We are not, like while evaporation, only water will evaporate. Correct. So the whatever be the mass or whatever be the number of moles of K2SO4, that is going to become unchanged. It is not going to change. So after evaporation also, this will be the number of moles of K2SO4. Right. The only thing which will change will be the volume. Right. So now the new molarity, M nu, I write, right, will be what? Same thing, number of moles of K2SO4, that is this value, 0.188 into 135 divided by 1000. That is the number of moles of K2SO4. Now, what is the volume now? Volume became 105 ml. 105. Again, you can put actually down 105. Again, it will come in the denominator only. Okay, divided by 105 into 1000. That's it. This is 188. Okay, very, very simple question. The only thing you have to understand is even after evaporation, the number of moles of K2SO4 is not changing. So you calculate the number of moles before evaporation and then use the same number of moles after evaporation, but you include the new volume. The new volume is 105. That's it. That's exactly what we do. Okay, I hope everybody is catching up. Everybody is doing good. Right? Okay, guys, I think we'll stop with this for today. Right? We will do some more couple of say 4 or 5 problems next class, and then we'll go for this, whatever I told you, this one, stoichiometry. Right? If I give you the information about one of the reactant or one of the product, how will you find out the difference between, how will you find out the information about the other stuff? That we'll do next class. Okay, fine. If there are no questions, then we can wind up, guys. Any question is there? Okay, fine, guys. Thank you so much. Yeah, fine. Thank you so much, people. We'll meet again next week. Thank you. Thank you so much.
Yes, sir.
Thank you.
Yeah.
Thank you, sir.
Yes, yes.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.